Hello everyone, my name is Michael Horn, and today there will be two videos completed, both for the final homework 4 for my separation processes class. And in part A, we're going to be completely working on the iPad, and in part B, we are going to be working in Google Colab. So for this first part, I will read you the problem statement, and that is we're going to be determining the degrees of freedom for an equilibrium stage, feed stage, reboiler, condenser, splitter, and a section of equilibrium stages in series. We are then going to determine the degrees of freedom for a distillation column and the typical set of column specifications for design and for simulation. So without further ado, let's begin. Okay, so the first thing that we're going to do is draw our system. And in this system, we're going to have a box. We're going to have this going out, we'll label as 3. This going in, we'll label as 4. We have our Q leaving. We also have 2 going in, 1 going out, and then we also have 5 going in. So to define the degrees of freedom for this, we're going to need to know our unknowns and our knowns. So first we will look at our unknowns, which we will write in blue. And so for streams, we have 5C plus 2. And then for Q, we have 1. And then for temperature and pressure, we have 2 times 2. Now we need to look at the knowns. And so the knowns for the material balance, we have C. For the equilibrium balance, we have 1. And then temperature and pressure, equality, expression, we have, you do TP times the number of outgoing, which would be 2 times 2. Then we also need our equilibrium expression. So for this expression, it's going to be equal to C. And then finally, our degrees of freedom. This is going to be 5C plus 10 plus 3 minus 2C plus 5. And you get the equation 3C plus 8 for our final degree of freedom equation. So now we have completed this first section, and now we are going to do the equilibrium stage. So this one we're going to set up a similar box here, and we will have our Q going out, and then we will have one stream going in, one stream going out, one stream going out, one stream going in. And so for this, again, we're going to break this down into our unknowns and our knowns. And so for this first box, we need to look at streams. And for this, we have 4 streams times C plus 2. And then we also have our temperature and pressure, which is related to 2. And then Q, flow, is related to 1. And so then for our knowns, our material balance is going to be C. Our equilibrium, Q, is going to be equal to 1. And our equilibrium is going to be equal to 1. And then our TP equal, it's going to be equal to 2 times 2. Now this allows us to solve for our degrees of freedom, and that is going to be 4C plus 1 minus 2C plus 5 to get you 2C plus 6 is our final answer for our equilibrium stage degree of freedom solution, and we're able to continue. Now the next step in this process is the reboiler. stage. And so for this, we'll draw our example, which is this rectangle. And in here we have this with a Q. We have our in and our out and our flow rate out. So let's begin with our unknowns. And for this, we have, again, same process, streams, which the equation for this is 3 times C plus 2. We have our TP, which is going to be 2, and our Q, which is going to be 1. And now we look at our knowns. And our knowns here, material balance will be C, equilibrium balance will be 1. Energy balance. I keep saying equilibrium balance. This has been energy balance. I'm sorry, energy balance. And then this is equilibrium. The equilibrium is C. And our TP is going to be equal to 2 times 2, which allows us to solve for our degrees of freedom to be 3C plus 9 minus 2C plus 5, which gets you the answer C plus 4 for our reboiler stage degrees of freedom. So now we have our condenser step, which I will write here. Condenser stage. We will draw our box per usual. Now we have this Q here. Now our in and out are at the bottom. So we're going to do our solve for this. Now, you could go and solve this all out algebraically, but if you look at the systems, they're actually completely identical, except that one's at the bottom, and one is at the top. So really, we could just go here, and we are going to copy all of this down, bring this down, and it's actually the same solution. So both the condenser and the reboiler come down to C plus 4. So now we have our splitter. Stage. And so for this, we need to draw another, which we have temperature and pressure. We have 2 leaving, hence the split, and then we have our Q coming out. So let's go over our unknowns, which is blue, not red. Shoot, oh well. So our unknowns, stream, obviously. The stream equation is 3C plus 2. Our Q is 1, and our TP is going to be equal to 2. Now, the unknowns can get a little bit trickier in this situation, or sorry, the knowns can get a little bit trickier because we have our material balance as C, we have our energy balance set to 1, but then if you look at the equilibrium, there is no equilibrium between our volume, our vapor, and our liquid. So we have a composition, therefore, of C minus 1, and then our TP is going to be equal to 2 times 2. So when we drag this all together into our degrees of freedom, we have 3C plus 9 minus 2C plus 4 to get you a final equation in this one of C plus 5. So now the next portion of this equation is going to be looking at it in series. And so to do this, we're going to go back to our equilibrium stage, and we're going to use all the equations that we found, and we are going to combine them all together into one equation. So you notice that we're going to start with n times 2c plus 6, which is this equation, and we're just going to continuously add all of these, minus 2 times n minus 1 times c plus 2 plus 1. And so now you're going to distribute all of this out, and you get 2nc plus 6n minus 2nc minus 4n plus 2c plus 5. Once everything cancels, you arrive at the equation 2n plus 2c plus 5. And this is going to be the degree of freedom equation for all of our items, or all of our stages in series. So now that we have this one, we still need to add the last couple. So we're going to go down to the bottom. We're going to bring that equation down. But first we're going to need our splitter. We need our condenser. We also need our feed, our reactant, and our stripping. So all of these, which we have already found, C plus 5, C plus 4, C plus 4, 3, C plus 8, and then this reactant and stripping is going to be the one that we just found, but we're going to say give it subscripts, so 2NR for reactor plus 2C plus 5, and then we have 2NS plus 2C plus 5. We combine all of these to find the degree of freedom stages in series, which we will combine all of these into 2NR plus 2NS plus 10C plus 31. And this is the big important equation that we have been looking for this whole time. We'll write this in red. This is the degrees of freedom stages in series. So now we're going to be looking at the degrees of freedom for this distillation of the entire column. So what we do is we draw out this box. And what we're going to do is duplicate this down, because there is going to be a total of 5 of these, but they will be a little bit different in each one. Duplicate this again. Duplicate again. So now we do have streams in every single one. I'm going to draw some in red. These red ones are going up, and the blue will be going down. And it is important to remember that we still have this leaving here, and at the top we have the same thing, in which up here we have that. Man, this is not being very helpful. So now we want to label all of these items, which I will do in green, and we are just going to go 1, 2, 3, 4, 5, 6, 7, and that box will be 8. And so when doing the degrees of freedom analysis for this, it is pretty simple. You count it up. You do, okay, well, we have -9 times our C plus 2, which we are going to then add into this previous equation. So you have 2NR plus 2NS plus C plus 13. And this equation is the degrees of freedom for the distillation column. Make this a little bit nicer. So the final thing, we're going to break it down a little bit more. And so the first we have the specifications of QP at each stage. And this is going to be -2NR minus 2NS, which results in C plus 13. And next we have the adiabatic splitter, which will become, oh, I'm sorry, I skipped a step. Just looking at my notes here. So first we actually need to do the specifications of the feed. and which is temperature, pressure, which would be negative C plus 2, which gets you 11 degrees of freedom. And then for this adiabatic splitter, just have negative 1, which gets you 10 degrees of freedom. And then for the specs of the QP feed, we have negative 2, which relates to 8 degrees of freedom. So total in all of this, when combining everything, you get the degrees of freedom for P condenser, P REB, and splitter. You get the degrees of freedom to equal 5. So we will review everything that I've done in this video. First, we took the degrees of freedom. Actually, I'm sorry. For the first part, we drew this large system. We drew to get 3C plus 8. We then went through our equilibrium stage, our reboiler stage, condenser, splitter, and then we finally broke it down into this distillation column where we arrived at this equation here. And finally, for our degrees of freedom, we equaled 5 as our final answer. So thank you so much for watching, and the next video will be all collab.